Hello everyone, in this exercise of the SolidWorks we will understand sheet metal base flange, edge flange and sheet metal corner relief in SolidWorks. Let's start and we'll create a model and later on we will flatten it and save it in the DXF file. Let's start. File, new, bar, OK. This is the SolidWorks user interface. I am selecting the background plain white and the unit system is millimeter gram second. Okay, I am I will make a arbitrary, I am making the arbitrary model. Okay, and I am taking the top plane, select the sketch, this one. I am taking the center rectangle, this one. This side, select this side, both are equal. Okay, and this one. I am taking this side, and shift this side and equal, make relation equal. Yes, this one. Smart dimension, I am taking this dimension 120. Okay, we will understand actually basic things in this one. Okay, and sheet metal, now I am going sheet metal base flange. This one. I am taking the sheet thickness 2 mm. Okay, but sheet thickness you are saying this is going below direction, below the sketch. I am taking above this one. You have to decide the direction as per your drawing, whether you have to take the dimension from bottom side or up side. Okay, K factor is standard. Rectangular relief we will not use in this case, and this one. And sheet metal, in sheet metal, if you right click, you can decide the radius. This 2 mm is the inside band radius of the sheet thickness. Actually, the rule in the sheet thickness is that the radius, inside band radius, must be equal to sheet thickness or more than that. Okay, K factor 0.5. I will show you how it can be measured. This one, edge flange, this one, this one, and this one. I am taking 3 edge flange. Now gap is 0.50 mm and inside band radius is 2 mm. If you uncheck this use default radius, you can still change the radius, inside radius. I will show you how to measure this inside radius and gap between the flanges. Okay, flange length, this is the flange length. These are the 3 position flange length. This is the outer visual shaft. Suppose I take front view, you will take this flange outer, first option means this is the height of the flange. This height is from the intersection point of this outer edge. This outer edge is intersection point from here to up to this one. This is inside. This is inner visual shaft, means this is from intersection of inner edges. This inner edges, that is from this one, and this is from tangent edge of the band to the parallel to the end of the flange. This is the third option. Okay, and this is the flange position. This is the flange length. I am taking 120 also. This one, flange position is this one. You will see this is the material outside. It means flange moves by 2 mm thickness equal to, and this moves, it means 2 plus 2. It moves this one, but I am keeping inside the band. Okay, material inside. This is material inside. This is material outside. This is band outside. Mostly we use only 3. This one. Okay, and I am okay. This one, isometric view. This is this one. Okay, now I use the color. You can give the appearance from here. I apply the appearance in this Future True Manager. This one, open this, click this arrow and select the part, and this one, and below the appearance, this one, edit appearance. I am selecting the green color. Okay, this one. Now I will provide a cut here. How? First select this sketch and take a line from here. This one. Okay. This dimension from here to here, I am taking 70 mm. And this dimension from here to here, I am taking 70 mm. Okay. Now, in sheet metal, extrude cut, this one, if you are seeing the direction of arrow is coming below, you can flip side to cut or click this arrow, this arrow, even up, and take the option through all. In this way, it will cut here. Okay, this is this thing. I am making this model arbitrarily. Okay, later on we will flatten it and save this file in the DXF for CNC cutting machine. Okay, now they are the extrude cut in this one. Okay, I am selecting this, but they are the extrude cut here, this surface, and this surface, and this surface. But I will make in these all sketches a complete sketch in one attempt. Okay, how? Sheet metal, unfold, select fixed face, and collect all bands. This one, this. Okay, this one. This is this one. So let's select this face, sketch. Okay, and I am drawing a line. This one. This one, and this line, select this line, shift, and this line, make parallel. Okay, draw two circle here. This one, and also another circle. Select this circle, shift, and this circle, equal. Okay, and dimension of this circle I am taking 6 mm, only 6 mm. Okay, now draw a line from midpoint. Yellow point is the midpoint. This one. Select this line, shift, and this line, and make relation perpendicular. Okay, this one. Now circle, dimension from here (30 mm). This dimension 30 mm. This dimension 40 mm. Dimension 40 mm. Fully defined sketch. Okay. Now the same sketch I will make here. How? I will mirror it, this one, from this line, midpoint of this one, central line, and mirror entities to mirror. Select this circle, this, and about this. Sorry. Delete. Also select this one, this one, Okay, mirror about this. You will see this is the mirror. Sketch is still fully defined. Okay, now draw a center line from here, this pinpoint. Okay, and I'm drawing the corner rectangle, this one. This is the corner rectangle. This line, shift this line, make equal square. But this line, shift this line, and this line make symmetry. Okay, this one. Now I am taking this dimension because this height is 120. I am taking this as a 30 mm. Okay, and this height, this distance I am taking 60 mm. So sketch is still fully defined. Okay, now this line, shift this line, this line, this line, I am making construction. Okay, I am making circle here, this point. So I am making this dimension as 6 mm. Okay, this dimension I am making 6 mm. Now, because this is a square, I will make a circular pattern of this hole. Okay, how? Firstly, make a diagonal here, so that we will make this one. This one. This one. Diagonal. This point, around this point, this center point of all diagonals, I will make the, either you can locate this one. Take a point in the sketch and locate this point, this one. Okay. From here, you can take a point and locate it here. Okay, now I am making the circular pattern. You will see. If this is a rectangle, then you can't make a circular pattern because all the sides are equal. It behaves like a circle. Okay, and select the point, this one, and select entity, this one. 4 circles we can make. Okay, underdefined. But this sketch is underdefined because center circle, shift, then this point, make concentric relation. Okay, this one, select this circle, shift, and this point, make concentric relation. Sketch is fully defined because this point is shifts. So in this way you can make this one. Okay, and now make one more circle here, that is 30 mm. This one. And this circle is 30 mm I am making. Okay, now on this surface, make it 2 circles here. But this make construction. Dia of this circle is 30 mm and dia of this circle make as a 60 mm. Okay. Our basic purpose to understand the sketch and how the sketch can be made on the sheet metal and how the sketch can be you should try the sketch and make fully defined sketch. Okay, you have to understand the concept of that also. Okay, this one. Now make another circle, or this circle, this one. I am making also this one as a 6 mm. Okay, now make a line, this one, and from here to here, and one line more, this one from here to this one, join midpoint. Yellow is the midpoint actually. This is the quadrant. Okay, and now make an angle, this angle and this angle. This is, I am making 45 degrees. Okay, now sheet sketch linear circular pattern, this one and this. Select this point and this one, sketch. Sketch is fully defined here, underdefined now. Now, in order to make the fully defined sketch, because the center of the circle shifted, it must lie on this circle. How? Select this and this circle. This point, you will see, this point shifted. Select this point and this circle, bigger circle, and make coincident. Okay, and the same way, this circle and this point make coincident. Very this point and this circle coincident. Sketch, you see, fully defined. So in order to make fully defined, you see the circle is shifted, center point shifted. Okay, in this way you can make fully defined. Now the sketch is fully defined. Okay, now you can go in the sheet metal, extrude cut, blind link to thickness. In link to thickness means the material will cut up to the thickness of the sheet. This is a very good feature in the sheet metal, and this one and this one. Now sheet metal, go in the unfold command. Unfold fixed space. This is the fixed space. Collect all bands. Collect all bands. And this is the fold command. Fold. Face, collect all bands. Fold. Now we want to float this one. This is the fold. This way we can make it this way. So, and now I want to show you what is the radius. I inside radius is what, how to measure it. Go evaluate, measure. This is the inside point. This is the 2 mm. You will see this radius is 2 mm. This is the inside band radius. We decide the radius when you decide the parameter in the sheet metal. Actually, this radius is this one, inside radius. Okay. Now one more thing, that is the gap. Gap is what? Gap is, you are seeing there is a gap between the flanges. So how you can measure this point, this one and this one. This one. You will see this is the 0.5 gap. When I have given the parameter 0.5. In this way you can measure the gap also. Okay. This one. This I have made a model how the extrude cut takes place, base flange, edge flange, and the relief corner. One thing I left, there is a relief corner. Actually, relief corners and the corners are used during the bending of the sheet, during the bending operation. Actually, there are the chances of the tearing of the sheet and deformation of the sheet during, if we don't provide the relief. So there is in sheet metal there is a command that is a corner relief. This one. In the corner relief, you collect all corners. 2-band corner, 3-band corners, and there are the different types of relief: rectangular, circular, as we seen in the base flange. On my channel, you can see the auto relief. I have made a separate full video for this auto relief. Okay, and I am taking, for example, circular. Okay, collect all corners and this one you will see this point. But this point you take centered on band lines. The band lines, it must lie in this one. And okay, and I am radius of the circle, this one 2 mm, this one. Okay, this you will see there is a relief. This is provided during the bending, and this is why this is provided, because during the bending there are the chances of the sheet metal tearing of the sheet and deformation of the sheet. In order to avoid the deformation and dimples, this relief is provided. Also provide in the edge flange, badge flange, rectangular relief, etc. Okay, the purpose of providing the relief is this one. This is the corner weld, corner relief during the bending. This is provided in order to safe operation of the bending operation. This is provided in this way. Now I am flatten it, because now this view, this is this part we can save in the DXF file. DXF file is applicable all the CNC machine, or that AutoCAD file. In this file, this file is applicable on ANSYS according to which program is given, and as per program and material is cut as per this shape. So how we make a DXF file? Right click on this one, export to DXF, and give the path of this one, and here save as type, this one, DXF file. Okay, save this one. Now this window appears. Select sheet metal. You can select different parameter, hidden edges, band lines, and forming tools. If there is no forming tool, bounding box, you can take. This is the bounding box, this one, and hit the right button, this one. This is the 2D file. This 2D file is in the DXF file. This is given. This is given onto the CNC machine for the cutting of the required part. Okay, and this way you can save this one. Okay, now you can make in this way DXF file, and how you can cut the base flange and corner relief is provided. I hope you would have liked this video, and you please like, share and subscribe this channel. Thank you very much.